So once again, we start by factoring things completely. Bottom is the difference of squares. So what are our non-permissible values? X can't equal 3. X can't equal -3. Are they going to be wholes or asymptotes? Both. Because the x plus 3, that's going to cancel out. Okay? Now, the number one temptation for students is once you cancel those out is to write this. Because they cancel out and this is what I'm left with. That's not quite right because that x minus 3 is in the bottom of your fraction. So it has to stay on the bottom of your fraction. So this isn't one that we can just do a whole and be done with it. We're going to have a whole at x equals -3. And a vertical asymptote at x equals 3. If we want to find the coordinates of our whole, once we've simplified it and we get our new equation, y equals 1 over x minus 3, we can plug in -3 to find out where the whole is going to be. And if you plug in -3 into this, you'll get 1 over -6. So that's the coordinates of our whole, but we still have a vertical asymptote at x equals 3. Again, once it's simplified, what I've written in the green box, that's what we're going to have to graph, but we're going to have to just add the whole to it. And that'll be the graph of what we need to find. So now, how do we graph this? Well, we would have started with our non-permissible values and found out x equals 3 would have been a vertical asymptote. And after you go through finding your vertical asymptotes, the next thing you're going to do is find out if you have any horizontal asymptotes or oblique asymptotes. The way that you can find that is look at the highest power. Now we're going to look at our green box, our new equation. What's the highest power in that whole thing? X to the 1. Okay? If you look at x to the 1, we have one of them on the bottom. We don't have any x's on the top. Does that fraction simplify or is that not possible? Simplifies to 0, so we have a horizontal asymptote at y equals 0. This one has no oblique asymptotes. X-intercepts. Again, looking at our function inside of that green box. Is the numerator ever equal to 0? No, it's always equal to 1. So there are none. Y-intercept. If you plug in 0 for x, what do you get? 1 over -3. So now that we have all of our information about all of our asymptotes and our intercepts, we can start by graphing this. We have a vertical asymptote at x equals 3. We have a horizontal asymptote at y equals 0. We have a whole at -3, -1 over -6. I'll label that. Oh, that's not a very good whole. There we go. 3, -1 over 6. We can draw our asymptotes. Our intercepts. We know that we have an intercept at 0, 1 over 3, negative 1 over 3. So as far as graphing this goes, do you see you have 2 points, one of them is a point and one of them is a hole, on the left side of our asymptote. We have no points labeled on the right side of our asymptote. So this is where you would plug in another point. I would suggest plugging in just one higher than your asymptote. So our asymptote's at 3, plug in 4. What happens when I plug in 4? I get the point 4, comma, go to our equation inside that green box, plug in 4. You can have 1 over 1. I have 4, comma 1. If you wanted to, you could plug in 2 and find out that you'd have 2, comma negative 1. So now as far as graphing this goes, towards your asymptotes, and through your hole, and this is what your graph would look like. So we graphed this one using what we knew about rational graphs and finding our asymptotes. Okay? Look at what's inside of that green box. Do you recognize you could have graphed this one from your transformations unit? One of our parent graphs was the 1 over x graph. And all this would do would move our 1 over x graph 3 to the right. Our 1 over x graph had the points 1, comma 1 and negative 1, comma negative 1. And when those are moved 3 to the right, you see you'd get 4, comma 1 and negative 2, comma negative 1. And your asymptote would get moved to x equals 3. So you could have graphed this with your transformations as well. The only thing different now is this one has a hole in it. So you just have to include that hole, because the original equation looked like this. Once it was simplified, it was an equation you had graphed before. So you could use those skills, or you could use the new skills that you have. So you have some options there. And there's our final graph. No questions on this one?